All right. Hi, everybody. We're going to grind through the first part of section 4.1 today, and then we'll stop and leave you some time to work on some stuff. Sound good? Yep. Okay. So in section 4.1, we're going to be talking about inverse trig functions. So we're going to be developing the inverse functions for sine, for cosine, and tangent, talking about how to use those things. So we're going to start by just kind of remembering what the graph we'll start doing this with sine, and then we're just going to kind of cut through to the end and show you just say what we get for cosine and tangent. But we'll do this for real with sine. So this is the graph of sine, just y equals sine x. If you remember back to chapter 1 when we talked about inverse functions, one way we can find the graph for an inverse function is to just take the x and y coordinates from our original function and switch them. Okay with that plan? If we do that, we're going to get something that looks like this. Everybody okay with that? If we look at that second graph, is there any issues that you see with it?
It doesn't pass a vertical line.
Yeah, it doesn't pass a vertical line test. So this is not a function, right? So this wouldn't be something that you could program into a calculator. It's not super helpful because it's not well defined, because for any given input you have lots of different outputs. Yuck. So what we're going to do, and what we typically do in this situation where we find an inverse and that inverse is in a function, is we go back to the original and we're going to restrict the domain. So we're just going to consider one section of this graph of sine x. And the way we're going to want to do this is we're going to want to just take a section that covers all the different y values that sine covers, but without any repeating values. So basically, if I take a section that goes from minimum to maximum or maximum to minimum, any section like that would be fine. Now, traditionally, the section that we use goes from this minimum to this maximum. But if I do that, all the different y coordinates that sine can have are still preserved, and none of those y coordinates are repeated. So that's going to be my restricted domain. So let's look at what that picture would really look like. So there's our new function where we've restricted the domain. So now the domain just goes from negative pi over 2 to positive pi over 2. And the range goes from negative 1 to positive 1. But there's no repeated y coordinates anymore, right? We just chopped off one section. We're just going to consider this one section. Everybody's okay? So now, if we swap the x and y coordinates, we're going to have something that looks like this. Does this pass a vertical line test?
Yeah.
Yes. And so here, now on the x-axis, we're going between -1 and +1. And the y-axis is going from -π/2 to +π/2, right? That if we switched the x and y coordinates to create this inverse, the domain and range would flip as well. Always okay? Any problems with what we've created here? From a function perspective, no, right? We're good. This is going to work just nicely. Now, from a practical standpoint, well, we're still going to have some issues. And we'll talk about what those issues are in a moment, but there's ways to work around that. Everybody's okay with this idea? And so what we do here is we create, we're going to call this the function sine inverse of x. So the way we write sine inverse is we use that little -1. That doesn't mean the reciprocal of sine. That means sine inverse, so that's not really an exponent, it's just like a superscript. The domain for this function, again, is going from -1 to +1, and the range is going from -π/2 to +π/2. And this is the function that's programmed into your calculator. So if I do second, well, let's make sure my mode, I'm going to put my mode in radian mode since we've done everything so far with radians. So if I do sine inverse of, say, 1, that gives me π/2. What that's saying is that at the angle of π/2, that's the decimal 1.57, etc., sine would have the value of 1. Right? Or the angle measure in which sine has the value of 1 is π/2. Everybody's okay with that idea? If I try to plug something in that's bigger than 1, say like 1.5, the calculator gives me an error. Why is that? The domain for this function is -1 to +1. You can't input something bigger than 1 or smaller than -1. Everybody's okay with that idea? Okay. So, issues with this, though. I know that, say, if we talk about a standard position angle, on the unit circle, that's the point 0, 1, right? That's what we just showed a moment ago. So that sine theta is equal to 1, or sine of π/2 is equal to 1. Is that the only angle where when we take the sine of it, we get 1? Wouldn't that angle also give us the sine of 1? Or that angle? So our sine inverse has a downside here in that it's not going to give us all the values for sine, or all the angles where sine is going to equal 1. It's only going to give us one of those, we'd be on our own to kind of generate any other ones we might need. So let's do some examples here of kind of doing that now, okay? All right, let's do that. So let's say I want to do sine inverse of, oh, shoot, before we get going, we shouldn't do this yet. We should define the other two trig functions. So we'll also have a cosine inverse. Its domain is the same as sines, but its range goes from 0 to positive pi. And we also have tangent inverse, whose domain is all real numbers, and its range goes from negative pi over 2 to positive pi over 2. Notice there for tangent I'm using parentheses rather than brackets. Anybody take a guess as to why I'm using parentheses rather than brackets? Think about the graph of tangent. What happens at negative pi over 2 and positive pi over 2 on the graph of tangent? Those are where the asymptotes are. So is there a point there? No. So that's why those are not included values, why we're getting a parenthesis there as opposed to a bracket. Is that okay? Okay, sorry about that. Now I'm ready to go and do the examples. I wanted to make sure, because I'm going to use some of these other ones while we're doing this. Okay. So let's say we want to do sine inverse of 0.62. And we're just asked to evaluate this. Well, I just go and I pull up my calculator, make sure I'm in radian mode, and then do sine inverse of 0.62 on my calculator and write down the answer. That's it. Everybody okay with that idea? Okay. So here we're asked to find the exact value for cosine inverse of 0.5. When you see the exact value in the instruction like that, what tool are we going to have to use?
Unit circle.
The unit circle. Very good. So I'm going to go and pull a copy of my unit circle. So I'm going to draw a little picture here. I know that the range for cosine inverse goes from 0 to pi. So in my unit circle, I have 0, then pi over 2, and then pi. So my answer that I'm looking for is in either quadrant 1 or quadrant 2. Everybody's okay with that? And then I remember this acronym from chapter 2, All Silly Turtles Crawl. What this acronym does is it describes what quadrants sine, cosine, and tangent are positive in. So A stands for all all of sine, cosine, and tangent are positive in the first quadrant. S stands for sine. Sine is positive in the second quadrant, but cosine and tangent are negative. T stands for tangent. Tangent is positive in the third quadrant, but sine and cosine are negative. And C stands for cosine. Cosine is positive in the fourth quadrant. Sine and tangent are negative. Everybody's okay with that? So in our problem, cosine is positive. So our answer needs to be in either quadrant 1 or quadrant 2 based on the range of cosine inverse. But where is cosine positive in quadrant 1 or quadrant 2? Just quadrant 1. So my answer is in here somewhere, right? I go to my unit circle and I remember the points on my unit circle. The x coordinates are my cosines and the y coordinates are my sines. So I'm going to look in quadrant 1 for the place where the x coordinate is 0.5. That's the spot right there. Everybody agree? And then I'll read the angle measure off my unit circle. So my answer must be pi over 3. Leo.
When you're trying to find out cosine is positive and negative, are you looking at 0.5?
Yes.
Okay. And then so why was it in quadrant 1 and not 2? Or so wait, why was it in the top half and not the bottom half?
It's in the top half because the range for cosine inverse is 0 to pi.
Okay, so it has to be positive.
So those angles are the top half, right? If you count around, you go 0, pi over 2, pi.
Okay, I see.
So those angles are going counterclockwise because they're positive.
Okay.
So going from 0 to pi is the top half of our unit circle. Does that feel okay?
Yeah. So why was it not on the S side? Where sine is positive?
Right. Because where sine is positive, that's cosine is negative.
Okay.
So can't be there because our cosine is positive. Cool?
Yeah.
Okay. So there's two pieces, right? There's the piece from cosine inverse, and there's the piece from whether it's positive or negative. Okay, let's do one more example like that. So I'll just call that example A. Okay, so here we have tangent inverse is negative root 3 over 3. Again, we're going to look for an exact value. The range for tangent inverse is negative pi over 2 to positive pi over 2. So negative pi over 2 is down here, and then we have 0, and then we have positive pi over 2 over here. So I'm looking for something in either quadrant 1 or quadrant 2. Or sorry, 4 or 1, right? Is that okay? Now, my tangent in this problem is negative. Between quadrants 1 and quadrant 4, where is tangent negative?
4.
Quadrant 4. Everybody agree? So my answer is down here. So I'm looking for this angle theta. Is that okay? So I'm going to go to my unit circle and I'm going to be looking in quadrant 4. Now I remember that tangent is y over x. And now I see a little bit of a problem, because none of the coordinates in my unit circle have just a regular 3 in it anywhere. Everybody see that? So what I'm going to do is I'm actually going to reduce this. You know that regular 3 is the same thing as the square root of 3 times the square root of 3. Is that okay? So I can reduce this down to 1 over the square root of 3. So what I'm going to look for is a y coordinate that has a 1 in it, and an x coordinate that has a square root of 3 in it, in the 4th quadrant. So that looks like this spot here. The x coordinate has a square root of 3 in it. The y coordinate has a 1 in it. Is there a denominator also? Sure, but I don't care about that. Is that okay? Joe?
So the 1 in the original function or problem, I guess, is a positive, but in there it's a negative. Does that not matter?
Does not matter. We've already taken care of the negative positive part by isolating the quadrant that we need to look at.
Yep.
Yep.
So it does, okay.
So the signs do not matter for this.
Oh.
Can you zoom in on those?
That feel okay? So the angle measure we're looking for is 11 pi over 6.
Do we need to draw the graph if we already know what the domain is? If you remember, all
silly turtles crawl?
Silly turtles crawl.
No, but the thing is I'm trying to explain how to do this, and I can't explain how to do it without drawing a picture to justify what I'm thinking.
Yeah, sounds good.
So yeah, these problems are things that you can realistically do without having to draw all this stuff out.
Okay.
Yeah. Okay? So far, so good? Okay. So slightly different wording. So here, we're asking to solve for theta, find the exact value for it, and we're told that theta has to be in this interval between pi and 2 pi. Everybody's okay with this? So I'm going to start by figuring out where on the unit or on my xy axis pi to 2 pi is. So I'm just going to count around in the positive direction, so counterclockwise. So I go 0, pi over 2, pi, 3 pi over 2, 2 pi. So we're looking here in quadrants 3 and 4. Everybody okay with how I figured quadrants 3 and 4? I do my all silly turtles crawl. I notice in this problem cosine is negative. So between quadrants 3 and 4, which one is cosine negative in? Quadrant 3. So the angle I'm looking for is this one. Everybody's okay with that? So I'm going to go to my unit circle. I'm going to look in quadrant 3 for the place where the x coordinate is -1/2. So it's right there at 4/3, or 4 pi over 3, excuse me. Leo?
How did you know that was the x-coordinate for cos?
So the unit circle is the x-coordinate is cosine, the y-coordinate is sine. Always on the unit circle, right? And just FYI, you can always check these, right? If I do cosine of 4 pi over 3, I'm going to get back -1/2. And if I check and look at the decimal, 4/3 has to be between pi and 2 pi. So there's pi. That's smaller than 4 pi over 3. And that is smaller than 2 pi. So it fits both criteria, right? It satisfies that equation and it lands inside the desired interval. So I know that I have the correct answer. Is that okay? Let's do one more example like this, and then we'll move on to the next kind of thing. Okay. So let's say we want to find find theta when tan theta is equal to -1, and theta is between 5 pi and 6 pi.
What does that mean? 5 pi. Okay, just go ahead, sorry.
Okay. So I'm going to start by figuring out where on my unit circle 5 pi to 6 pi is. So 0, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. So starting here and going to 6 pi. So I have quadrants 3 and 4 again. Is everybody okay with that? I didn't draw the ones on the y-axis because it was just going to be, there's a lot of times, a lot of things to write down. No reason that we really need it. Yeah, exactly right. So I'll do all silly turtles crawl. Tangent is negative in quadrant 4. Good. So now I'm going to draw my angle. So to get there, I go one full time around to 2 pi, another full time around to 4 pi, and then around to my answer. Is everybody okay with that? So again, I remember that tangent is y over x. So I'm going to look for the place in quadrant 4 where the x and y are the same value but opposite sign. So that would be right here. Everybody agree with that? Same values but opposite signs? Joe?
So I understand what you did, but how come the sign matters now, like the positive negative matters now? Do you understand what I'm trying to say?
So it doesn't matter which one is positive or negative, just that one of them is.
One of them.
Because right now we need y over x to give us -1.
Oh, then, okay,
right?
That makes sense.
So all I need is the two things to be the same, but one of them
equals,
negative.
Okay.
Because it has to divide out to get -1.
Yeah, makes sense.
That's all.
All right.
So my angle here is 7 pi over 4, but that is not my final answer. What's wrong with that?
7 is 2, 5, 6.
Good. 7 pi over 4 is in between 5 pi and 6 pi. Right? If I look at the picture I've drawn, how many times did I go around before I could go to my answer?
Twice.
Twice. So what I'm going to do is I'm going to find an angle that's coterminal to this point that is between 5 pi and 6 pi. Since I went around 2 times, what am I going to be adding to this?
2.
I'm going to be adding 2 pi twice. Right? 2 pi is a full rotation. If we want something coterminal, we're going to add or subtract 2 pi. 7 pi over 4 is too small, so I know I'm going to be adding rather than subtracting. And because in my picture I went around 2 times, I'm going to be adding that 2 pi twice. Is that okay? So I make a common denominator here. It becomes 8 pi over 4. And when I add those together, I get 23 pi over 4. And again, I can check this. So if I do tangent of 23 pi over 4, I'm going to get -1. And if I compare this to 5 pi, and then I see that it's bigger. If I compare it to 6 pi, I see that it's smaller, so I know that I have the correct answer. Riley? Of course. Is that okay with everybody? All right. What happens if actually, hold on one second. I can't remember. I don't want to get off. I forget where we ended. Yes, or with the other section. I want to check real quick. Okay, so we did do that. All right, good. Yep. All right, back to here. I couldn't remember where I stopped in first hour. I didn't want to go further here than there. Okay, so let's say we want to just solve for theta. Notice in the directions here, we're not asking for an exact value. And notice in the problem that what sine theta is equal to is not a unit circle value, right? So we're not going to be using the unit circle to do this. We have to use our calculator. Everybody's okay? But the calculator alone is not going to give us our answer, because our answer from the calculator can only be between negative pi and negative pi over 2 and positive pi over 2, which is not the value of theta that we're looking for. So we're going to have to do a little bit more here. Just like before, though, I'm going to start by figuring out what quadrant I'm working in. So 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, and then 7 pi over 2. So we're looking at, quadrants 2 and 3. Everybody's good with that? So using all silly turtles crawl, which quadrant should sine theta equal negative 7.6 or 0.76 be in?
You said negative sine?
Yep.
third, right?
Yep. So there's my theta. Notice I went around more than once. Plays good? Nothing different so far, right? Here's where the difference is going to come in, because we can't now go to the unit circle to look up this value. We're going to have to compute it ourselves. So what I'm going to do is I'm going to define another angle here. That's the angle made between the x-axis and the terminal side. I should say the acute angle made by the x-axis and the terminal side of theta. I'm going to call that angle alpha. That's the fish symbol that I drew there. Alpha, in our case, is going to equal sine inverse of the absolute value of, in this case, negative 0.76. Alpha is always going to be the absolute value of whatever you're taking the inverse of. Is that okay so far? And now what I'm going to do is I'm going to find an equation to relate theta, the end of my x-axis, and alpha together. I can see that from here to here is 3 pi. And then 3 pi to the terminal side is alpha. So I can see that theta is equal to 3 pi plus alpha. So I can go to my calculator now. 3 pi plus sine inverse. And I'm not going to do the absolute value on the calculator. I'm just going to do the absolute value in my head because, well, I can drop a negative sign pretty effectively. And so that gives me 10.29. Just so that we can see that this does indeed work. If I do the sine of this number, I should get back negative 0.76, which I do. That number should be less than 5 pi over 2. I'm sorry, bigger, which it is, and less than 7 pi over 2, which it is. Joe, you have a question?
Yeah. So since we're not using a unit circle and you drew that like little the point along the x-axis, you got to 3 pi by just counting how many times you went around. I'm kind of confused.
So the 3 pi was there when I figured out what 2 quadrants my answer could lie in.
Okay.
Right? So I drew these in. I just went 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2.
Right. Okay.
So whatever is at the end of my x-axis
That's what you used.
is going to be what the 3 pi is in the
Okay.
equation. So if that was like 7 pi, or if it was on the other side, if it was on the other side, it would be 2 pi.
Right.
But it's whatever, when we make our angle alpha, we're just using that end of the x-axis
Okay.
whenever we make it, depending on whether our alpha is on the left side or the right side.
Okay. Sounds good.
Does that feel okay?
Yep.
Great. Let's do another example of that. Let's do actually this. And then I need that to be negative. And just something silly like that is fine. And then we'll do this plus, oops, this would be a theta. Doesn't really matter, I guess. And then that should be that. Yeah, okay. Okay. So one thing right away should jump out at you on this example. What do you notice that's here decidedly different than what we've seen before?
There's no negative on the sine. Wait, do we even have sine?
You have secant.
Yes, yeah.
Which is not one that we've used yet, right? So remember back to chapter 2, secant is the reciprocal of which one? Sine, cosine, or tangent? Cosine, very good. So I'm going to replace the secant with 1 over cosine. Everybody's okay there? Now I got to get the cosine theta out of the denominator here if I'm going to try to solve this thing. So to do that, I'm just going to do the reciprocal of both sides. So I'm just flipping both sides. So this is really the equation that I'm going to worry about solving. Everybody good with that? Okay. Now back to normal. So let's figure out what quadrant we're going to be working in. 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, 9 pi over 2, 5 pi, and then 11 pi over 2. So we're going again in quadrants 2 and 3. So far, so good. I'll do my all silly turtles crawl. What quadrant is cosine negative in? Quadrant 2. Wait a minute. They're both of these. Here, I just goofed up. Let's do this. We're just going to make this cosecant. So that's sine. So that's sine. So now it's quadrant 2. Sorry about that. Sometimes when you're making them up in your head, you wanted to do one thing and then you just... Yeah, you know. Anyway, so to get to this, go to 2 pi, go to 4 pi, and then go to our answer. So there's my theta. So far, so good. I'll draw my angle alpha, which is here. So alpha is going to be the sine inverse of the absolute value of negative 1 over 2.5. And then if I look at the relationship between theta, alpha, and 5 pi, I notice from here to here is theta, there to there is alpha, and that's going to end at 5 pi. So theta plus alpha equals 5 pi. I can subtract alpha from both sides. So theta is 5 pi minus alpha. And then I go to my calculator. So I get 15.30, I guess. And again, if I wanted to check that, I'll notice that sine of that number does give me 1 over Oh my, great googly moogly. Okay, let's just do this. This will make life easier. Joe answered the wrong thing for me. When we put sine in the second quadrant, should have been in the third quadrant.
Yeah. I thought we were talking about the other one.
That's okay. It's my fault for changing things. But like rather than moving everything around, I'm just gonna just pretend it was a positive value the whole time through. It makes the changes so much easier. So that works. Notice that 1 over 2.5 is 0.4, right? And then this value is between 9 pi over 2 bigger than that, but smaller than 11 pi over 2, which it is. So notice when we did this, over here we were adding theta or adding alpha. In this problem, we subtracted alpha. There is a way to predict that. So if theta is a positive value, just double check here. Okay. So if the last axis you pass when drawing your theta is horizontal, we're going to be adding alpha. If the last axis passed is vertical, we're going to be subtracting alpha. So just if we go back to these pictures real quick. In this problem, the last place that we crossed, or the last axis we crossed, is right here, right? So we're adding. In this problem, the last place we crossed was the vertical, so we're subtracting. So notice this is only for positive values of theta. What do you think is going to happen if the theta is negative?
Division and multiplication.
Nope. They just reverses.
Oh.
Instead of the horizontal, instead of adding, we'll subtract. And if for the vertical, we're going to be adding. And the reason that happens is because when you're talking about a negative angle, instead of going counterclockwise around your axis, you're going clockwise, right? You're going the opposite direction. Let's do an example with negative angles here. Sound good? And then this is where we'll stop. This will be the last example we'll do today. Okie dokie? Okay. I went slow and maybe we took a little bit more than half the time. I'm sorry. I thought I'd be going faster. It happens though. Okay, I need to do something like that. So let's say we want to find tan theta equal to 3.7, where theta is between negative 4 pi and negative 3 pi. So we'll start the same way. So 0, but because we're talking about negative angles, this time we're going clockwise, so negative pi over 2 is down here, negative pi is over here, negative 3 pi over 2, negative 2 pi, negative 5 pi over 2, negative 3 pi, negative 7 pi over 2, and then negative 4 pi. So we're talking about quadrants 1 and 2. I'll do my all silly turtles crawl. So what quadrant between 1 and 2 should tangent be in if tangent is positive?
Can you put it in 1?
Should be in quadrant 1. Keep in mind we're going the clockwise direction. So here to here is negative 2 pi, and then to our answer. That's our theta. Our alpha is always the acute angle made between the terminal side and the x-axis. So our alpha in this case is tangent inverse of the absolute value of 3.7. Big whoop. Might as well just be tangent inverse of 3.7. But I'll put the absolute value bars on there so you don't forget to do that. Everybody's okay? Now, here, what is the last axis that theta passes through? Is it vertical or horizontal? Mm-hmm. It's right there, right?
So that's vertical.
So that's vertical. Everybody kind of see that? That's why the picture is helpful. So since it's theta is negative, and the last axis we passed through was vertical, we should be adding theta according to the criteria we just listed. So you don't have to really look at the picture and come up with what you're doing. And what should we be adding theta to?
To alpha, right? No.
Or I'm sorry, what should we be adding alpha to, not theta? We should be adding it to negative 4 pi, because that's the end of the x-axis that we put theta on. And then it's calculator time.
So it's the same as the last one, you're just going backwards.
Yes,
Kind of.
yes, very much. The same, still the same. Nothing new really happened here. You just have to make sure you're drawing things in the right direction. But it's still the same process. So negative 11.26. Again, if I want to check this, tangent of that value is 3.7. That's good. Negative 4 pi should be less than that, which it is. And negative 3 pi should be bigger than that, which it is. So we are done. Okay? For the remainder of our time together, I'd like you guys to start on worksheets 1 and worksheet 2.